What equation is going to apply here?
360 equals 128 plus 128 plus 20 plus 4x.
You got it. And that's all you need. I mean, I know you can solve for x.
Yeah.
Once you get the general equation, that's 90% of the problem. Let's divide x in number 2.
X squared plus 75 squared plus 75 squared equals 125 squared. Right?
You said x squared plus 75 squared equals 125 squared?
Yeah.
Yep. Okay. Number 3.
Well, first you'd have to find the height. So, 25.
Blow this up because I'm having a hard time seeing this. And having multiple choice doesn't help a whole lot here. So I don't mind covering up some of those answers. Let's see, have they given us all the information that we need?
No, not H.
You're right.
Lower.
Didn't give us H. But they gave us an isosceles trapezoid. So if we look at that front face, as long as it's an isosceles trapezoid, that gives us a lot of information. Because now we can figure out these little triangles. In other words, that's 32 and that's 46. What's x?
7.
And that's h. And they gave us... I'm sorry.
7, 24, 25.
What's that?
Isn't that a
Yeah, I think it is.
primitive?
I think it is. Do you have your calculator in front of you?
Yeah.
See if 7 squared plus 24 squared is equal to 25 squared. Because I think you're right. I think there is a 7, 24, 25 triangle.
Yep.
Okay, so surface area is going to be what? Let's start with that trapezoidal face. What's the area of both it and its opposite side? Because it says it's a trapezoidal prism. So not only does that have to have exactly the same dimensions, but that's parallel with this. What's the equation
So it
for
has
area of a
base 1.
Okay, which is
46.
correct.
Plus base 2, so 32. Divided by 2 times 24.
Okay. How many of those faces are there?
2.
Okay, so let's go ahead and multiply by 2. That takes care of... I'm
You
sorry?
don't have to do that.
What's that?
Wait, you have to multiply it by 2?
Well, we're talking surface area here. And there's 2 of these surfaces. So that's the only reason I multiply it by 2. You can wait until you get the answer and then multiply it by 2. But, you know, it's half a dozen of one, 6 of the other. In other words, we know this front face is a trapezoid and the back face is the same trapezoid. So that's why I multiplied it by 2. Okay. Plus what? That handles the trapezoidal faces. What else do we have?
This box are rectangles.
Which one? Yeah, actually everything left is a rectangle. So,
The two side ones.
okay. Or what?
So 25 times 38 times 2.
Okay. Now we got all of the lateral faces. The only two left are the top and the bottom.
So then 32 times 38 plus 38 times 46.
Okay, I'm just checking. Okay, plus what?
32. Oh, 38 times 46.
That's it. That'll give you the total surface area of that thing. And the next question is find the volume, which is a lot easier. Notice, finding volume is almost always easier than finding surface area. What's the volume going to be?
Base times height separated. So 46 plus 32 divided by 2 times 24 times 38.
Very good. Very good.
I like volume.
Yeah, no, volume's easier. Volume, especially of a prism. It's, like you said, the area of the base, and I like the way you put it. It's not the height, it's the area of the base times the separation between the two bases. Hold on a minute, let me blow this down a little bit so we can get it in the picture. So find the area, what's that structure called, that thing there?
Kite.
Okay.
So it's a 3, 4, 5 primitive.
What's the general formula for the area of a kite?
Diagonal 1 times diagonal 2
That it?
divided by 2, I think.
Yes. And the way you can figure it out, let me show you. There's diagonal 1. There's diagonal 2. Let's create a rectangle about that kite. What's the area of the rectangle?
Area of a rectangle?
Yeah, the one I just drew. What is it?
Diagonal 1 times diagonal 2.
And clearly the area of the kite is less than the rectangle, correct?
Mm-hmm.
And we know that these relationships are almost always 1/2 or 2. So if you had to guess as to whether the area of the kite is diagonal 1 times diagonal 2 or 1/2 of that, you would certainly see from doing this that it would have to be 1/2 of that. Now let's figure out what our diagonals are. What's the horizontal diagonal?
16.
What's the vertical diagonal?
8.
No,
15.
this part is not 8. This part is something else.
I was thinking of the primitive. Isn't it an 8, 15, 17?
It is, so that makes the bottom part of the upper diagonal 15.
And then the top is 6.
Correct, so it's 21. So the short diagonal is 16, the big diagonal is 6 plus 15, and we're going to divide the whole thing by 2.
Okay.
It's the general equation. The way to solve this problem is to start out with the general equation for shaded region.
X over 360 times pi r squared.
Well, you're right. It's the shaded region is the area times the central angle of the shaded region divided by 360. In other words, that represents the percentage of the circle that we're talking about. In this case, what is the central angle of the shaded region?
160.
Okay, so that's 160 over 360. And the area is pi r squared. And what they gave us was the shaded region. So we're going to fill that in there. These kind of problems, the most important problems to start off with the general equation. Especially when they give you the shaded region. In other words, when they give you the number that is on the left side of the equation, these are the ones that you really want to start off having an equation that you can just fill in and hope that you only have one variable to solve for. And that's the case. In other words, I can solve for r. And that's what they asked for. All right. Really, they have to give us these giant numbers. Ah, there's a method in their madness, I think. No, there isn't. What equation do I have to use to solve this for angle B? Having multiple choice doesn't help a bit.
Oh, it's cosine. No, sine. Cosine.
Law of cosines. Why? Law of sines requires you to have an angle and an opposite side. And we don't have that here. What we have is three sides. In other words, this is side, side, side. Side, side, side always requires you to use the law of cosines to get started. So does side, angle, side. Neither of these two give you an angle opposite side relationship. So you have to use the law of cosines to start out. Okay, so get me started.
Shoot, I know this. Okay, it's oh no, I'm forgetting it now.
Let me help you. Start it off like you would start off the Pythagorean Theorem. In other words, one side is equal to the other two sides. One side squared is equal to the other two sides squared, right?
2AC.
There you go.
Cosine.
It's called the law of cosine, so it's got to be cosine. What angle?
B.
Okay. Now fill in. What's B squared?
Well, 390 has to be the biggest side, or angle.
Well, no, hold on. We've labeled it as B because it's opposite the angle that they want us to solve for. In other words, we're trying to solve for that. So this is always going to be B. That's 390 squared.
So 390 squared equals, the other ones don't matter, right? 350 squared plus...
Well, they matter. Yeah, they enter into the equation for sure.
Well, they don't matter which one's which.
No, they don't.
And then these ones, when we were like learning this, I kept making the mistake. So
Well, this is the toughest one because, in other words, this is side, side, side is harder than side, angle, side. When you do side, angle, side, you're solving for a side. Okay, so there's only one calculation. You're solving for the B. But when you do side, 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 you're always solving for an angle first. And this is, first of all, you got to solve for cosine of B. Solving for the cosine of B is relatively simple, right? I mean, we just do all of these. We square that, square that, square that, add them together, multiply those together, subtract those to the other side, divide by that coefficient. You end up with cosine of B being equal to some number. We'll say 0.8. Without wasting the time to go through the calculations with their giant numbers like we did. One thing we could have done to simplify it a little bit is take the zeros off everything. In other words, I could have made this 35, 39, 38. And it would have had to give me the same angle B, right? In other words, having the triangle be just 10 times bigger doesn't change angle B. So I could make the math a little simpler by dropping all the zeros, but I'm still going to end up having to do it on a calculator. But it still would be easier if I didn't have all those extra zeros. But my point is that you're going to get down to some point where the cosine of B is equal to a certain number after you go through all the algebra. Now, how do you get B? Let's say the cosine of B was equal to 0.8. What's B?
Then you have to do cosine, like on, what's the negative one cosine thing?
Like what?
Well, the negative one cosine.
It's inverse.
Inverse.
It's got a negative 1, but it's not really what you think of when you think of negative 1. It's not 1 over cosine. That's not what it is. It's the inverse cosine of 0.8. Really, the way to think about this is when you have this right there, the way to solve it is to take the inverse cosine of both sides. Take the inverse cosine of that side, take the inverse cosine of that side, and when you take the inverse cosine of the cosine, what you have is B. So you have B on the right, you have inverse cosine of 0.8 on the left. Whenever you have either the cosine of the inverse cosine or the inverse cosine of the cosine, you have whatever that is, that angle is. Okay? You see why dropping all the zeros doesn't change anything?
Yeah.
Yeah, because you still have a similar triangle. In other words, if I had a triangle that was 35 by 39 by 38, well, that angle B is the same as that angle B, because they're similar. Similar triangles have the same angles. So I could help myself by dropping all the zeros, but that's about the only thing I can do to simplify this problem. And let's just make sure that we understand this. Let's talk about, we take trig functions of angles to get ratios. We take inverse trig functions of ratios to get angles. And this is an if and only if proposition. If the sine of 30 degrees is equal to 1/2, the ratio 1/2, then the inverse sine of the ratio 1/2 is equal to 30 degrees. So whenever you're solving for an angle, you're going to need to be taking the inverse trig function. When you're solving for a ratio and they give you the angle, then you always take the trig function of it. But notice that if I wanted to look at it, I could just take the sine of both sides. Well, now I have 1/2 on the left equals the sine of 30 degrees. So that always works also. But make sure you understand the difference between the trig function and the inverse trig function. All right. Let's see. We have a session tomorrow also, I think. No, we don't. We have one on Wednesday at 3:30. Does that work?
Yep.
Okay. I'll talk to you Wednesday, Quade.
Alright, bye.
Bye-bye.